Good day, I'm Pieter Rademeyer, the Agronomy Manager for Pannar Seed, and today I'm going to talk on the second part of maize pollination and fertilization. Today I'm going to focus on the female part, and let's kick off. The cops and the silk is basically the female part of the maize plant. Now, like I said in the previous talk, the cops of the maize develop in a very early stage, like the 5-leaf stage. And genetics is the driver behind prolificacy. So if you have a single ear or a multiple ear plant in the end, genetics is the driver behind that. Now, inside the cop you will find a ovary, a style and a stigma. And in the end the ovaries will develop into maize kernels. The style is basically the silks of the maize plant, and on that style or the silks you will find fine hairs, and that fine hairs function as the stigmas. Now, silk starts elongating around about the 12-leaf stage, and you must bear in mind that there must be some order inside that cop. If you take a cop with 1,000 kernels, all that silks in the end pushes to one opening to get to the outside. So there must be order inside that. Even the husk leaves, if you open it closely and you look nicely to it, you will see there's fine corrugation that lead the silks towards the opening. Now, the first silks that you see will be the ovaries at the base of the cop, and then it progresses towards the tip of the cop. Problems with silk appearance. Silk can get scrambled inside the cops, and there's a lot of factors that can lead to this phenomenon. And the first one of all is temperature. If your temperature is more than 10 degrees apart, minimum and maximum, it can lead to scrambled silk or silk balling, silk jamming inside the cop. And when the minimum temperature drops below 10 degrees, you can be for sure, you must look out for this phenomenon. Chemical sprays, maize streak virus, drought stress delays the process of synchronization, and also drought stress plant leads to the weak uptake of pollen. The R1 stage represent the reproductive stage number 1, and that's actually when you see the first silks on the plant. Normally it takes anything between 3 and 5 days for all the silks to appear, and heat and water potential are the drivers behind the growth process of silk. So let's see, the moment if the silk appear on the outside, it is immediate receptive for pollen. Now, pollen can germinate any place on that silks. The silks are viable for about 6 to 10 days, and for kernel development, the pollen must land on the silk, and it's captured by the small little hairs. You can see in that picture on the top, the hairs there is called trigomes, and the pollen then germinates any place where it lands. It grows into that tube, and it grows down to the ovule to fertilize it, and that takes normally 1 day. So it's a very quick process in nature. Factors that influence silk receptivity. Wilting. If the plant's wilted, the silks will be wilted also. Silks is last in the line for water uptake from the plant. So if you have a dry spell, the plant will look after himself to survive. So moisture is then used for plant survival. Now, silk growth is the quickest and the fastest during the first 2 days after appearing, and then it slows down up to day 10. So silk growth is the quickest in the early hours of the morning. And what's interesting, the husk covers, the husk leaves around the cop also give some protection for that silk against dry out. Factors that influence silk receptivity. Temperatures, anything between 32, 34 and higher. Then silks become unviable. Low humidity. What's interesting, if silks become unviable for 1 day and the circumstances improve the next day, it will become viable again. In warmer areas, pollination takes about 3 days to complete, and in the cooler areas it can take up to 5 days, because like I said in the beginning, heat is one of the drivers behind silk growth. Now, silk can grow up to 10 days if not pollinated, and if you look at that picture, if you see that long silks, you can for sure know that pollination will have a problem. Looking at pollination and fertilization, basically pollination is when the pollen lands on the silk and germinates. So it can only germinate in an environment where enough moisture is available, and that moisture comes from the silks. Now, unfertilized eggs on the cob leave a gap or an opening, and you will always see the kernels around that gap and opening fill that gap with more rounder shaped kernels. Now, pollen divides into two sexual cells called gametes. The one fertilizes the embryo and the other one fertilizes the endosperm. And you see it very often if a yellow plant pollen landed on a white plant's silks, and then you have a yellow kernel in that plant because of the fact that the yellow is dominant over the white. This process is actually known as double fertilization, and not many plants do have it. Now, normally silk detaches from the cob, and you can do an easy shake test. You take all the husk leaves off the cob and you shake it, and silk should actually drop to the ground if it's been fertilized. If it's still attached, you know the fertilizer wasn't that good. Okay, problem cases. Stress can lead to weak seed set, and then you get aborting of kernels. There's various reasons therefore. Diseases, leaf loss, insects, heat and cold again, and all of those have a reduction on the yield. And then I'm going to stipulate two chemicals, 2,4-D and glyphosate. If you spray it at the wrong time onto the plant, then you can have severe yield loss due to aborting of kernels and weak pollination. And stress also can lead to weak synchronization. I'm going to sum up. The pollination and fertilization process is by far the most important stage in the maize plant's life. Bear in mind, one seed that you plant can easily give you 600 to 1,000 kernels back, so the return on investment is quite pretty good. Any stress in the end will erode yield potential. Nature has the biggest influence in farming success, and all I will say, try to minimize the risk factors by adapt farming practices. And somewhat you can do: plant the correct hybrid at the correct planting window and at the correct plant density. That's in a nutshell from my side, maize pollination and fertilization. I thank you.